Well, this is a NIH-funded project. It's a program grant. There are many collaborators in Washington, D.C., Chicago, and Parma, Italy. The question is how the brain learns to recognize other people's actions. Some work has been done in young people, adults, but very little is known about infants, about how this system develops in the first years and months of age. Right? So I would say this is one of the first studies that really asks the question, how development affects your capability to understand other people's actions and behaviors. This is good for communication, as I said before, but also we think that helps you to acquire motor skills, right? So what Rachel and other members of the team are doing is basically asking the question in young infants that are freely behaving, right, during interaction tests, social interaction tests, what it takes to the brain to develop patterns of brain activity that eventually lead to the behavior that we are seeing.
I applied for the Methodist Hospital Caring Teen program and the Research Institute program, and I was accepted into both. And I asked if they had any outside activity to do with working with exoskeletons or biomechanics, and they said that they had Pepe's lab.
And I told her about some of the different projects, about the exoskeleton work, about the infant work. Because she was new to the area, I thought it would be important for her to understand, human experimentation and perhaps, in addition to the training in terms of the EEG, I think she will be very good in helping out with this study with infants.
I mean, I knew I wanted to do something with biomechanics, but I didn't know a lot about the individual activity going on at different colleges here in Texas.
One of the goals in my lab is to reverse engineer the brain, right, to understand how the brain works. Because the more we know about the brain, the more we can design interventions for people with disabilities.
We conduct this research first by recruiting babies, and then the babies come in, we fit them for EEG, we set up the cap. There are a total of 64 channels plus the grounder reference on each of these splitter boxes. There are 32 channels. There are 32 yellow, 32 green, and so you just place the electrode with the correlating port. One splitter box for the yellow, one splitter box for green, and then you have the cap set up. So this is an adult-sized cap, and then you have an infant-sized cap. This is a 44. Once you have the electrode set up in the port and you put the cap on the head and you start gelling, what the gel does is it increases the conductivity between the brain waves and the electrodes, and so that's how the computer is allowed to read the brain waves.
We teach computers how to identify patterns of brain activity that repeat over time whenever a specific behavior appears, right? So it's like mapping, apples to oranges. So we are mapping these two, and there are features on the EEG that predict specific behavior. So we can track those features, how they evolve over time as the kid learns or improves on their skill. Because you get better at doing things, you repeat those behaviors.
Because eventually this research will be used to determine factors relating to autism, I think that the whole freely behaving part allows us to really see, the natural behavior of the babies and what they would naturally do in the situation. And because we're just freely interacting with them, it just allows them to behave exactly as they would, as if they didn't know it was an experiment.
We have plans to collect data from about 80 infants through the end of December, and at the same time we collect the data, we process the data, and we have already submitted some conference papers, and we will eventually submit a full paper for peer review where we report our findings. And of course, the next step is going to the clinical application. And Rachel mentioned autism. That's very important because these kids have problems with social communication, with interaction. So we think what we learn from this project is going to be very important to understand autism and perhaps devise ways to help those children. I think outreach in science, technology, mathematics, engineering is very important, and we need to do it early on when they are forming, when they don't have yet an idea what they want to do with their career, right? So my lab has an outreach program for K-12, right? And we have been, welcoming students through demonstrations or internships in the lab, and Rachel is one of them. So I think this is very important to me, and it's very important to the university, and we hope that Rachel will come and to UH and become an electrical engineering student, right? Maybe go to get a PhD and do research, right? So that's very important.